Okay, right at the end of last class, we discovered that if we completed the square for the general form of a quadratic equation, if ax squared plus bx plus c equals 0, that we could solve it using completing the square, and we got a formula. And that formula is what's known as the blinking thing up here, the quadratic formula. And the quadratic formula is a formula that will work on any quadratic equation. We just figure out what A is, we figure out what B is, we figure out what C is, we plug it in the formula, and we will get the answer. The part under the radical here, the b squared minus 4ac, is referred to as discriminant. That is the part, and we'll talk about what relationship the discriminant has to the quadratic formula. So, what we're going to do is, we're not going to find the value of discriminant yet. We're just going to identify, we're going to solve this problem, all right, using the quadratic formula. So, for this first one, remember the quadratic formula is x equals negative b plus or minus the square root of b squared. Let me write that a little nicer. B squared minus 4 times A times C all over 2 times A. So that's our equation right there. So we're going to simplify that, and that'll be x equals 9 plus or minus 81 minus 80 over 2. Or x equals 9 plus or minus the square root of 1 over 2, which is 9 plus or minus 1 over 2. And a lot of people make the mistake of stopping here. It's important to remember that these are actually two different problems. This is 9 plus 1 over 2, or it's also 9 minus 1 over 2. If we solve this, our two answers are 5 and 4. So we got two rational answers. In this case, two integer answers, but two rational answers. Incidentally, you could have also done this problem by factoring, and that's what we'll talk about that later in the video. The second one here is not ready to be put in the quadratic formula. Remember, in the quadratic formula, the equation must be set equal to 0. So A is 1, B is 7, and C is negative 5. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. It'll give me negative 7 plus or minus, oops, the plus or minus came out wrong, plus or minus the square root of 49 plus 20. Because a negative and a negative is a positive. And we'll end up with x equals plus or minus, negative 7 plus or minus the square root of 69 over 2. Now normally you would reduce the radical, but square root of 69 cannot be reduced. So in the black problem on the left, we got two rational answers. And in the red problem, the problem on the right, we got two irrational answers. And remember, that means there's two answers because we're going to both add the square root of 69 and subtract the square root of 69. And what determines what type of answer choices we get is the discriminant of the quadratic formula. And this discriminant of the quadratic formula is the part that's under the radical, b squared minus 4ac. And one of four things happens. B squared minus 4ac is positive, right, greater than 0, and is a perfect square. Then there will be two rational roots, two numbers that could be expressed as fractions. If b squared minus 4ac is greater than 0 and is not a perfect square, then there will be two irrational roots. The answer will have a radical in it. If b squared minus 4ac equals 0, then there's only going to be one answer, and it will be rational. And if b squared is negative, then we wind up with a negative under the radical, and so the answer will contain I. There will be two complex roots. So let's try this. Now we are going to find the value of the discriminant only. We're not going to solve the equation. So A is 1, B is 6, C is 9. So all we're looking for is the discriminant, b squared minus 4ac. In this case, that'll be 36 minus 4 times 1 times 9, or 0. So if we were to, this equation will only have one rational root. Because what would be under the radical in the quadratic formula would be plus or minus the square root of 0. In the second problem, b squared minus 4 times a times c would give me negative 11. So this is a negative number. We're going to end up with a negative number under the radical, so we'll end up with two complex roots. We'll end up with a root that contains I. Now mind you, in these problems I'm not asking you to solve them, I'm just asking you to tell me what type of answers we're going to get. For this third one, we would get b squared minus 4 times a times c, or 64 plus 16, which is 80. 80 would be what winds up under the radical in the quadratic formula, which means that 81 is not a perfect square, so we will end up with two irrational roots. There will be plus or minus something in a square root in our answer. For this last one, we would do b squared minus 4, sorry about the bell, times a times c, or 121 minus 40, or 81. 81 is a perfect square root, so we will wind up with two rational roots. We're going to have to add or subtract some number to our final answer, but it won't be a radical. Now, this is how that last slide was how I was taught to solve quadratics and how to identify the types of roots. Fortunately, we have access to graphing calculators. In the graphing calculator, we can get the exact same information by looking at the graph of the functions. If we graph them, we can look at the x-intercepts and know that those are the roots. So if we just look at the roots, we can tell that same information. Here is that first one, and we had said in our original answer there would be one rational answer. Well, sure enough, right there, there's going to be one answer. On the second one, where we remember we got negative 11 as our discriminant, notice there are no zeros. The graph never crosses the x-axis. So we know that there's two complex zeros. They're going to contain I. If you were to graph these and you were to use your calculator to find these zeros, right? If you were to plug this formula in and use what we learned last time, where you left bound and you right bound the zeros, you get some crazy long decimal. And it's a crazy long decimal because it's in irrational number. It never repeats, it never ends. And so this is two irrational roots. If we graph the last one, we'll see that the zeros go right through integers. And so we know that that's two rational roots. Now the only danger we have is that sometimes if these go through fractions, it's difficult to say whether they are an irrational or rational just by looking at them. But if we actually use the calculator to find the decimal equivalents of the zeros, we can tell the difference between a repeating decimal and a number that goes on forever without repeating. Okay. Those last examples were to find the answers, or to find out what type of answers. But it didn't actually give us the answers. If we actually want to give the answers, we have to use the entire quadratic formula. So the entire quadratic formula is right here. So let's go ahead and use that to solve this equation. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Now, you cannot type this all into your calculator at once. It will not work. You're going to have to do it step by step. So we'll get negative 4 plus or minus 16 minus 16 over 2, or negative 4 plus or minus the square root of 0 over 2. Well, that's just negative 4 over 2, and so your final answer is negative 2. Once again, the discriminant came out to be 0, so there was only one answer. If you were to look at it on the graph, it would look like, sorry, a little bit off there. Nope. If you were to do it on the graph, you would wind up with a graph that looked like that, where it would only touch at negative 2. Let's try this number 2 in the quadratic formula. So, negative b plus or minus the square root of b squared minus 4 times a times c. And it's a good habit of always put your plugged in values into parentheses. That way when you type it in the calculator, you get the right answer. So this is negative 3 plus or minus 9 minus 20 over 2. Or x equals negative 3 plus or minus negative 11 over 2. And now we have a problem because we have a negative under the radical. So if you remember, what you would do here is you would factor out a negative 1 and turn that into I. And there's your final answer. And that's not there's no real answers, there's only complex answers because it's plus or minus I times the square root of 11. All right. Remember that when we solve the equation must be set equal to 0. This is not. So we're going to add x squared to both sides, and we'll get x squared plus 2x minus 5 equals 0. So the solution is x equals negative b plus or minus the square root of b squared minus 4ac over 2 times a. Or x equals negative 2 plus or minus the square root of 4 plus 20. And it's plus 20 because it's a negative times a negative is a positive, over 2. Or x equals negative 2 plus or minus the square root of 24 over 2. And a lot of people try and stop there. But we have to remember that the square root of 24 can be reduced. As 2 times the square root of 6. So down here we would write x equals negative 2 plus or minus 2 times the square root of 6 divided by 2. But we can cancel the 2's. And we'll end up with x equals negative 1 plus or minus the square root of 6. All right, here's another problem. Now, this one's a little tricky. A is 9 and C is negative 4. Because remember, it's ax squared plus bx plus c equals 0. B is what's in front of the x term. There is no x term here, so we would say that b is 0. So we can still use the quadratic formula. We just go 0 plus or minus the square root of 0 squared minus 4 times a times c all over 2 times a. And what we'll get is plus or minus the square root of 144 over 18, or plus or minus the square root of, plus or minus 12 over 18. And then we reduce the fraction, we'll get x equals plus or minus, top and bottom are both divisible by 6, 2/3. Now, I've told you that the quadratic formula will always work, but I've also told you it's not the easiest way. If you ever have a problem where the b term is 0, the easier way to solve it is going to be to isolate the x squared. Move the 4 to the other side, divide both sides by 9, and you get x squared equals 4/9. When you have a squared number equals something, we can solve it by taking the square root of both sides. The square root of 4 is 2. The square root of 9 is 3. And we get the same answer that we did when we used the quadratic formula, and we got it much easier. So my recommendation is if you see the b term is 0, solve it by isolating the x squared term and taking the square root of both sides. Here's another one. This one is not prepped yet for the quadratic formula. So it would be 5x squared minus 20x equals 0. So a is 5, b is negative 20, but c is 0. There is no c term. So when we do it this way, it's going to be, so x equals negative 20 plus or minus the square root of negative 20 squared minus 4 times a times c all over 2 times a. Or x equals 20 plus or minus the square root of 400 over 10. Or x equals 20 plus or minus 20 over 10. Two answers here then. 20 plus 20 over 10, or 20 minus 20 over 10. And I'll get 40 over 10, or 4, or I'll get 0 over 10, or 0. So those are my two answers. Our solution set is 0, 4. Now, just like when b was 0, it was easier to isolate the x squared and take the square root of both sides. If c is 0, there's an easier way to do this problem, and that is to factor it. If we take this equation right here and move it, and we go 5x squared minus 20x, I'm sorry, Smartboard's being weird on me. Being very weird on me. 5x squared minus 20x equals 0, and I factor out a 5x, and I can use the zero product property, either 5x equals 0, in which case x equals 0, or x minus 4 equals 0, in which case x equals 4. And my solution set is because if there's no c term, it's very, very easy to solve by factoring. So, in review, we've learned 5 different ways to solve a quadratics. The first one is take the square root of both sides. That will not work if there's any b term at all. If there's a b term at all, we're going to have to use another method. If there's a b term, we can factor, but that is easy but doesn't always work. We can graph it and use the calculator to find the x-intercepts, or the zeros, but it's a lot of steps, and it only gives you decimal equivalents. It doesn't give us exact answers. We can complete the square, but you have to remember the process. Find b, divide it by 2, square it, add it to both sides, then factor each side individually, or you can use the quadratic formula. The quadratic formula always works, but there's lots of chances for arithmetic errors, and you have to be able to reduce radicals. The sub is now going to give you worksheets to work on. So have this and the homework from last class ready to go on Monday, and I'll go over any questions. Everybody have a wonderful weekend.